Hi everybody, so today's lesson is on sections 3.1 to 3.4, word problems and then solving the word problems. So as a reminder, for every word problem, we have to make sure we write a let statement. So let's just look at a basic problem. 22 less than, I'm going to underline less than because that's important, a number is -7. What is the number? As a reminder, we're always going to get our variable for what's unknown, and the unknown is always given in the question. What is the number? So I'm going to let n equal the number. Let n equal the number. Okay. So then we have to interpret the word problem, and it says 22 less than a number. Less than's a flip it around word, so that means I know it's going to be -22 because the 22 has to come second, not first, even though it's first in the sentence. So 22 less than a number, there's my number, so n minus 22 equals -7. All right, so now we have to use the skills that we've been talking about to solve. We want to balance the equation by doing the opposite operation to the 22, so we're going to add 22 to both sides. And we'll get n equals -7 plus 22. So different signs, subtract the numbers and keep the sign of the larger. So 15. Now remember, you can go through a check. You can go through a check by taking your 15 and evaluating the expression when n is that number. So is 15 minus 22 equal to -7? And it is. That's the nice thing about these problems. You can always check them. All right, moving on. Karina ran 400 meters, a 400-meter dash in 56.8 seconds. Is that good? I'm not sure. This was 1.3 seconds less than her previous time. Well, obviously it's good because she did better than the last time. What was her previous time? So there's that question. What was her previous time? So I'm going to let, I'm going to let X, okay, because I don't want to use T for time because T looks like a plus. So I'm going to let X equal Karina's previous time. Okay, so if I take her previous time and I subtract 1.3 because she did it in 1.3 seconds less, that's going to give me the time of 56.8. Okay, so I took her previous time, I subtracted that 1.3 because she did better, she went faster, and the time that she got on that faster time was 56.8. All right, now I'm going to go through the process of solving. I do the opposite operation, so in this case I'm going to add 1.3 to both sides, and I'm going to get 58.1, and we want to make sure we put seconds, because these are word problems, okay? 58.1 seconds. Okay, moving on. A little harder. Carrie bought a picture frame on sale for $4.69. A week later, she returned to buy another frame. However, she had to pay the regular price for the second one. If the two frames cost Carrie $10.64, how much had the store reduced the price for the sale? Well, first of all, we have to understand she's bought two frames. So, and they totaled $10.64. So remember, you're looking for things that will tell you, am I adding? Is it a total equation? This is a total equation, so I know I'm adding two frames, and they are going to equal 1064, okay? All right, but we need to write our let statement. So we're going to let X equal the amount the store reduced the price. Okay. So let's think about it. The first picture frame she bought for $4.69. So here's frame one. She paid $4.69. Now, but that was a reduced price. So wouldn't the other frame have to be $4.69 plus whatever they reduced it by because it was the regular price? So I took that $4.69, I add the reduction to it, whatever it was reduced by, and then I totaled $10.64. Okay, I go through the process. A little bit harder only because I have to combine the like terms before I balance. All right, so $4.69 and $4.69 is $4.70 times 2. which is $9.40, and then I have to subtract 2 cents, so $9.38. So $9.38 plus X equals $10.64. Okay, so then I'm going to subtract $9.38 from both sides, line up my decimals. So that's 6, I have to reduce that by 1, 2, and 10 minus 7. $1.26, does that look right? 10. Yep, that looks about right. So $1.26 was how much she got off of that first frame. Okay. All right, so I'm going to have you jump to the next page. Okay, jump to the next page, and I will go back. I want us to go to the problem that says special example. And let me just check how I'm doing on time with you today. Perfect. Special example. We're going to look at, I like these special examples, and these are going to come into play when we start talking about linear functions. But oftentimes you're going to see questions in algebra that involve like a fixed cost by a changing cost to get a total cost. All right, and here's a very basic example. Lynn took a taxi cab from her office to the airport. She had to pay a flat fee of $2.05. She's paying that no matter what. She gets in the car, it's $2.05. Plus 90 cents per mile. The total cost was $5.65. How many miles was the taxi trip? All right, so we're going to go through our let statement. We're going to let M equal the miles. Okay, we're going to let M equal the miles of the trip. All right, so my flat fee, that's my fixed cost. That would be $2.05. That's not going to change. There's that word that helps me, plus 90 cents. Hopefully you know the word per mile. Per means multiply, so I multiply it by the miles. So 0.90 M equals 565. Okay, so what I'd like you guys to do is I'd like you to solve that and bring the answer to class, because I want to make sure that you're okay with subtracting and dividing by decimals.